We're going to jump into lesson 8 in a couple minutes. But this, to me, hits on a lot of key points, like practicing degree, leading coefficient 8 times, typing a function into the calculator 8 times. I don't have the graphs done out. I remember that this one kind of looked like this, and this one kind of looked like this, right? Something like that. So both of these, what did they have in common? They both had a degree. This degree was 2, this degree was 10. They both had even degrees. Listen up. Not all of you did this. I'm going to give you the quick summary. These two graphs both had even degrees. Look what they look like. They also both had, this had a leading coefficient of 2 and this had a leading coefficient of 2. They both had a positive leading coefficient. We're going to write down a summary in a minute, but if you notice, both ends are pointing up. That's important. Now, when you look down at these two graphs, I really don't remember what they look like. Did the third one look like the upside down parabola? And then did they both look like upside down parabolas about? No. Which one had the extra point? Three had a like squiggle. I don't know. The key point is, whatever these two look like, they both pointed down. So their degree, let's see, this was a degree of 6, which was even. This was a degree of 4, which was even. The even is what's making your arms go in the same direction. So either both go up like the touchdown, or I both go down. What's the difference between going up and down? The leading coefficient. See how the leading coefficient on number 3 was negative? It was negative 1. And on number 4, it was negative 3. So I tried to put two graphs next to each other so that you could start to see and predict what's coming. So if you ever have an even degree, let's say you have y equals 4x to the 6 minus 2x plus 9, that even degree means they're going to go in the same direction. Then you're looking here, and that's going to tell you they won't go up or they won't go down. So I don't know what the rest of the graph looks like, but they're both pointing up. So you can predict what the graph will look like. It's called the end behavior of the graph. One thing that this curriculum does that I don't do, I would just call this the right side of the graph. I say the right side goes up. Over here, I would say the left side goes up. They use a lot more words. They say as x goes towards constant infinity, the graph goes up forever. Right? This is going towards constant infinity on the x-axis. Or they may say as x goes to the left forever, the function goes up or down. So I just say stand up, left hand down. You'll see on their multiple choice that the words are a little bit more wordy. I forget exactly what these look like, but the big idea is that all of these kind of look like one arm up and one arm down. So like the disco move, like one arm up and one arm down, or whatever move that's called. So notice these have odd degree on this page. This one had a degree of 3, this one had a degree of 5, so they were both odd. And their leading coefficients were both negative. So do you see my right side of the graph is pointing down towards the ground? So when the leading coefficient is, was this negative 3? You don't have to fill this all in, but negative 1, it's negative. And the bottom ones had the opposite kind of swoosh. The right side was going up this time because it had a positive leading coefficient, and they're going in opposite directions. So I think of odd as opposite. Odd, opposite, they both start with the letter O. Let's see, this had what? A degree of 3, a degree of 5. So if you spent some time yesterday, you did 8 practice problems on degree and leading coefficient. This one should have been 2, this would have been 3. Just to make sure you got those answers right. If you did it yesterday, did you check? So what I wanted to do was actually skip ahead to today's learning target and write the rule down very from the first get-go. So if you look under, let's see,
summary right down on your paper. Okay. And if you notice, I already put them as day 8, day 9, right here. It says, I understand why a function's end behavior is determined by the leading term, and I can identify the end behavior of a polynomial from its equation. So the big idea is, I'm going to draw a graph and say that this is the right side of the graph and that this is the left side of the graph, so that when I'm writing these rules down, you know what I'm referring to about left and right. So you always do the leading coefficient first, because you have to know what the right side of the graph is going to do. If it's positive, the right side goes up. Hey, you finished? How'd it go? Did you get better at? So step 2, we're just writing the learning target down so that we have the rules, and then we're going to use them a lot today. So second, we look at the degree. If the degree is even, they go in the same direction. And if the degree is odd, they go in opposite directions. Odd opposite. Maybe underline that the O, odd opposite. So to me, that's like the big idea of today is we're going to be looking at a lot of these graphs and deciding what is the side of the graph going to do. I just use the really simplified language of up or down on the left and right. You'll have to read a little bit more under their questions to understand what they're talking about. As x goes forever in the left section, what does the function do? Does it go up forever or down forever? They use a lot of words. That's all they're talking about. I thought if we did this first and laid it out like very clearly, what are the rules? And now if we do some of these problems, so like I actually think we could skip 8.1 the warm up and jump into 8.2 the table. And then before lunch, we might be able to play something called the pose game, where I'm going to put a function on the board, like I'll put this function on the board, you'll all stand up and think about it for a minute, and then I'll go like 1, 2, 3, and you all put your hands like this, right? So this would be up on both sides, up, go like this, right? So it makes you think about what the graph would look like. All right, so turn to this table. I'm only going to have you do like kind of one of the columns, and then we can kind of fill it in. So if like you three would kind of each do like one of the functions, like you do this one, copy this one, and Matt does this one. It's 8.2. So you guys, if there's kind of 4 of you, right? So you each took one of the functions, you put your function into an menu, and then maybe you can trade. Does that make sense? You don't have to do every single function. Yeah, who needs some calculators? Let's see. So you're going to put your function into the y equals menu. If you just want to write like kind of big positive or big negative, I mean, it just gives you an idea. As x gets really far left, right? Isn't negative 1,000 really far to the left of the x-axis? What is that side of the graph doing? It's shooting way up to 1,000,000. And then as x goes all the way to the right side of the graph, 1,000, that side of the graph is shooting up. So if both of the sides of the graph are shooting up, right? It's like touchdown graph. Up. Don't feel like you have to write in all of these numbers. If you wrote in 1 or 2 of them, that's fine. We are going to, it says like question number 2 says, sketch what you think the end behavior of your polynomial looks like. So just whichever one that you did. So let's say I did this one. You're just thinking about what would the end behavior have looked like. At negative 1,000, 1 million, 1 billion, wouldn't trillion be here? Quadrillion? I'm not sure. A really big number. That means that the right side of the graph would be shooting way up, and the left side of the graph would be pointing downward. Right? So if I was just looking at this function, I would kind of sketch that. I don't know what my x-intercepts are right now. I know the right side went up and the left side went down. So pick one of them, whichever one that you filled out from your calculator, and just sketch a graph kind of like this over to the side. Did your right end go up or down, and did your left end go up or down? I just think the table is a really easy way to visualize, wow, these got really big, but these got really big in opposite directions. Negative infinity, positive infinity. So just take like 1 more minute to sketch the graph. You can copy my column. That's fine. If you want to just write that example next to it, that's fine. This is good practice on looking at end behavior from a table. So on a test, if they did not give you the function at the top, they just gave you a table, but you explain in words what the end behavior of the graph is. When x is really far to the left, the graph is pointing down. When x is really far to the right, the graph is pointing up. Because they could just give you a table without giving you the function. So you can't look at the graph, you have to figure out what the graph looks like from just clues in the table. Give you 1 more minute, and then we're going to play the pose game. None of you are going to stand up and put your arms up? No, I will. Okay. So we are skipping ahead to 9.1 and looking at matching the graph to the equation. Okay. I think these are not right. Well, I don't know. I'm not going to say where this one and this one don't count for the same answer. Positive x to the fourth, positive x squared. As x gets larger in your positive and negative direction, f of x gets larger in the positive direction. So that's the answer number one for both of them, but what did the book say? Yeah, they said A and B are both number one. A, B, and C, actually. See, this is positive x to the fourth, positive x squared, positive x to the fourth. It gave you the four different possibilities, like this, or this. All three of these just went with number one. But it says some end behavior may not have matched your polynomial. Okay, as long as you know how to do end behavior, was there another problem that you did right? Larger in the negative direction of x is larger and larger in the negative direction. Yes. Okay. Because it goes down on the left, right? Okay. Then the degree is even. Okay. As long as you feel like you know that I'm not. All right, should we talk about these two just so you can move on? Can you give one to him as well? Thanks. All right, you're done. Where's the other part of your test? You staple it all together? Oh, then this is it. Can you staple that together for me? Where's the Mayan what? Mayan. Is it right there? Did Orion just pick it up? Orion. Oh, I think you took well, I didn't just put it away. Okay, I'm talking quick about this so you can try a few of those practice and get them done before you do the cool down. Describe the end behavior. Oh, I shouldn't have erased it up there. What did you say? M for the right. Does it go up or down? I'm looking at this. It looks like the right side goes down. What about the left? So if it's odd, they go opposite each other. So if it goes down on the right, it must be going up on the left. Does that kind of make sense? And then n, this is the key term to look at, negative 20x squared. So I would say the right goes down again, right? Because of the negative. What does the left do this time and why? Negative 20x squared, what would it do? It has to go the same direction. I'm not going to give you this so you can kind of see where we are. I'm not going to have you redo a bunch of stuff, but I can explain a couple things here. Okay, and then it says when x is greater than 0, so that means when x is positive, which function do you think has greater values? I don't know. Let's think about plugging in. So I've got that, and I've got negative 20x squared plus 3x plus 8. If I plug in a really big negative number, I'm not telling you, if I plug in a really big negative number and square it, what happens? I mean, negative 100. If I square negative 100, what would happen? It becomes positive, but then I'm multiplying by negative 20. So you're still at a pretty big negative number. What happens when I plug in a positive number up here? Oh, sorry, I'm plugging in a positive number for x, right? So positive number squared times a negative, positive number cubed times a negative. Which one do you think is going to have a bigger output value and why? Which one is going to have a larger value? I'm plugging in a big value, like 1,000. Which one of these is going to be a more negative number? If I plug in 1,000, isn't cubing going to make it even more negative? And if I just square it? So I think if you're looking for the greater value, I'm predicting that I don't have a greater value, but I would have to look it on a calculator. But I think a cube is going to be more negative than a square, right? Let's see, if I plug in negative x to the third minus 2x plus 8, and I also plug in negative 20x squared plus 3x plus 8, and I go to my table at like negative 1,000. I'm looking for which one is more positive. Wait a second. Must have plugged in something wrong. That should go, they both should go down on the right. Oh, did I just go to negative 1,000? I'm going to go to positive 1,000, sorry. I can't think about that big of a number. How about negative 100? No, how about positive 100? Which one is less negative? Ugh. How about we go to 10? Okay, I can think about this. So when I plug in a positive number like 10, which of these is a greater number? This is a tricky one. Which of those is a bigger number? No. So if you actually were in debt, you want to owe less money, right? So this one is actually a bigger number than this. So remember I said that x cubed could be bigger. I'm not really sure what the point of this problem is. Hold on. What does it say they want you to figure out? Which one is the less negative number? I think n is greater than m. Well, values of n are greater for small values of x. Like that's those functions that I can see the values of x are greater around 20. So for big values of x like a million, the negative x cubed term is much, much less than the negative 20x squared term. Because of this, I think n of x is greater. I feel like that was a bunch of garbly-gook, but when you think about the steepness of a curve, this negative x cubed is going to look like this, and this side, the parabola, is going to look like this. They want to know who is higher. So they're x cubed. I feel like that was not, I should have omitted that activity rather than the other activity. So I wouldn't worry so much about number 2. Number 1 is where you need to get with the end behavior. All right, so okay, so we looked at the end behaviors and we decided that this was the end behavior for M and this was the end behavior for N. Oops, N would have to be both down. And then we were thinking about which has greater value. If I plug in a big number like 1,000, this is going to have a very negative value, and this is going to have a somewhat negative value. Cubic is going to go more negative faster than this one, so this would actually be greater because even though it's negative, it's less negative than a cubic function. So now you are doing practice problems 1 through 3 on lessons 8 and 9, and then the cool down.